Okay, happy Wacky Wednesday. I hope everybody is happy. The sun is shining, but when you are watching this, it's probably going to be snowing. Okay, so we are finishing our workbook page from yesterday, and then we're getting into a game. People at home, you're going to need a geoboard, just like we will need a geoboard. And the pages in your workbook have the game, so you don't have to download anything. Okay, so moving on, I'm going to show you what we are working on. The class has already worked on this, so I'm going to call students over to give us answers. Okay, so who would like to tell us about Mariah, who ate 2 slices of pizza? So, but first of all, we have to go back up here. The 4th grade class won a pizza party. Oh, hey, we should win a pizza party. What you think? No. Yeah. Okay, getting back to our work. Medium pizzas were cut into 8 slices and large pizzas were cut into 12 slices. She ate 2 slices of a large pizza. What fraction did she eat? Who's going to tell me that? Okay, Reese. She says 2/12. Because it was 12 slices and she got 2 of them. And we could draw a picture and get that all going. But we're going to move on really fast because we want to get to our game. Okay, Carlos and Mariah ate 1/6 of a pizza. Tell why you agree or disagree. Could they eat 1/6 of a pizza? What you think there, Grace?
Yes, because 2/12 equals 1/6.
Okay, she's telling me 2/12 equals 1/6. Okay, so there I've got 6 pieces. I decided I had to draw this anyway. So if they ate, Ethan, I want you at your seat, please. Okay, so if they ate this piece and that piece, there's 2/12, and this could also be 1/6. So yes, she did a nice job of telling us. Okay, looking at number 3, Mariah's table seats 4 students. Okay, just like Anna's table in front here. So we'll use Anna's table as an example. Each student ate 2 slices of a large pizza. Yeah, they're all happy about that. Write an equation that shows what fraction of the pizza was eaten at, we're changing this to Anna's table. Okay, who thinks they know? Millie.
I don't really have an equation, but I have a fraction.
Okay, well, we have to get a fraction. Okay, how many students are eating pizza? 4. How many pizzas does each student have? 2. However, which pizza is it? The 8-slice pizza or the 12-slice pizza?
12.
It is the 12-slice pizza. There's our equation. Or we could do 2/12 plus 2/12 plus 2/12 plus 2/12. What would you rather write? 4 times 2/12 or write 2/12 plus 2/12 plus 2/12? Oh, you guys are all liking this way better. Okay, so we're thinking about equal groups. Let's count that now. You're going to count with me to come up with the answer, and then Millie, you'll tell us if we got the right answer. So here we go. 2/12, 4/12, keep counting with me, 6/12, 8/12. And Millie's shaking her head yes. She came up with 8/12. Okay. And we should really be labeling these numbers of a large pizza. I'm going to want pizza tonight for supper, I think. Okay, it says Tony ate 3 slices of a medium pizza, and his friend Connor ate 4 slices of the same pizza. Write 2 different fractions to describe how much pizza Connor ate. Who thinks they can do this? Okay, Phoenix. Okay, what's another way of writing that he had 4 slices? Yes, sir? Okay, I could also say we had 2/4, or we could say that he had 4/8. What's the name of these kind of fractions? Everybody say the word? Equivalent. Okay, So, now we got to figure out how much did Tony eat and how much did Connor eat all together. What is the fraction for that? This has been, okay. Okay. Oh, I was just distracted. Can you please tell me the answer to letter B again? What is it? How much the fraction of the pizza did the boys eat, everybody? 7, what? 8. That's because Tony had 3/8 and Connor had 4/8. How come did I know that it was 8ths, Marshall? Or somebody on Marshall's table? How come do we know that it's 8ths and not 12ths? David?
Because it's a different equation.
Because I'm a little bit more than that.
It's a medium?
It's a medium pizza. Tucker wanted to say that. Okay, because it's a medium pizzas, and up here it says medium pizzas had 8 slices. Okay, and then Lionel's table drank 1 1/2 liters of juice with their pizza. Oh boy, do you think you know how much that is? We have not studied this, so this might be hard. Okay, so if we look at our word wall, and for some of you, there's such a glare, it's hard to see, but I have seen people get up to look at it. 1 liter equals how many milliliters? Looking at the word wall. People at home, we've got a word wall. I'm sorry that you don't have that, but we were telling you about it. Okay, Phoenix is trying to give me sign language here. So how much is it, sir? 1,000 milliliters. Now I make the cursive L like that because a printed L looks like a 1. So I just make a cursive L. Okay, but that's not what it's asked us here. Now I have to know what a 1/2 liter is. So 1/2 liter equals how much? How do we figure out a 1/2 liter? A whole liter is 1,000 milliliters. So what's a 1/2 liter? Millie says 500. So are we finished? No, because we still haven't answered the question. How many milliliters did they drink all together? They drank how many, Will? 1,500 milliliters of juice. Okay, and we just did a quick review on how to multiply these numbers. I am just going to go through this quickly so you can make certain your answers at home are right. So I'm going to say the equation and the class is going to shout out the answer. 100 times 45 is? Okay, 79 times 10. 790. 100 times something is 8,500. It is? 85. Okay. 20 times something is 1,400. 70. Okay. Something times 40 equals 240. 35 times something is 7,000. 60 times 60.
136.
3,600. 6 times 6 is 36, times 10 is 360, times another 10 is 3,600, because we have to think about it. 6 is times 10, and this 6 is times 10. We have to do times 10 twice, or in other words, times 100. Okay, this is the game, but we have some things to do first. Yesterday, we had started writing all this stuff down, and it got really long, and we just discussed it. So instead, for today, I have it in a chart. Isn't this nice to have? So let's look at our chart. It's probably easier to read. Okay, I'm making certain Gabby's table's ready to listen. Oh, they're shaking their head. 2 of them are shaking their heads at me. Okay, how about Adrian's table? Are you guys ready to learn? Kiona, turn your chair. Oh, I forgot that you can do that. I'm sorry. Don't mean to be yelling then. Okay. So notice our regions. Does anybody remember us talking about a half of something on our large square yesterday? And then it went down to a 1/4, and then it went down to and it went down to, okay, so we have all of this stuff. How many of you remember getting this thing or seeing this yesterday? Okay, those of you at home, I'll make certain that I have attached this so you can use it as well. Let's talk about our fractional area. Do you remember yesterday I made on my own geoboard, I had the white piece of paper and I was trying to write underneath it and I was trying to be so careful. Well, letter A. What is the fraction of the space for letter A? Millie? 1/2. I'm going to write 1/2 in there. Luke, keep your hands off. Thank you. Letter B. What is my fraction? This letter B takes up how much space? Ethan, put the pink things back. I took them away for a reason. Jacob.
1/4.
It is 1/4. Going to C. What fraction of this is this? Akaya. 1/8. Okay, so is Anna brave today? Does Anna want to say what region D is?
I can talk for her.
Okay, Reese. Oh, Reese's eyes got big. 1/16, Anna says. Okay, and Gabby, are you brave? No, she says she's not brave, but maybe we can help her out. What is that fraction there? 1/32. I'm going to write it over here just because otherwise it's hard to read. So I put a little arrow over here. I'm going to pass everybody a paper like this, and you're going to get your geoboard. People at home, while I pass things out, you have a break. So we'll be back with you very soon. Hello, we are back. We had a moment to play with our geoboards, and it was so sad to put them away, but we know that we have learning to do as well. This is the game that we are going to play. And to play this game, I need to demonstrate it first. Otherwise, it is very confusing. However, as you play this game, you can do this with us. People at home, I am not certain if this game is available as a digital version or if you will need to go back and forth with your geoboard, your virtual geoboard, your digital geoboard. Okay, so let's see. Our senior math helper would happen to be, let's see, is it Jared or Adrian? Jared, have you been on for 2 weeks or 1 week? You've been on for 2 weeks. So, Jared, sorry, you're playing against me.
I can't play. I know.
Okay. And when Jared and I play this game, Jared's going to be this side. I'm going to be this side because you can see his name's over here. Now, Jared, I am going to make some of the decisions for you, okay? Because you don't know how to play the game yet, correct? Okay, so Jared's okay with that. So what we would do is, well, actually, Jared could come over here if he wants to do a spin. Would you like to spin? Okay. I'm going to be nice. It says whoever's the youngest player gets to go first. I really should get to go first because I'm only 3. What? Too bad you couldn't have saw Jared's face when I said that.
3 plus how much?
Jared spun an 8.
If you're 3, why are you a teacher?
Because I'm really smart.
You are.
That explains why I'm not taller than some of you. Okay, and I spun a 16. Now I need all of you to listen a moment. It's time to be serious. I joke around sometimes, but it's time to be serious at the moment. Thank you for your attention. I need to arrange the numbers 8 and 16 into a fraction that is not greater than 1. Did you hear how I said that? I have to arrange these two numbers into a fraction that is not greater than 1. How would I arrange the 16 and the 8? What should be the numerator and what should be the denominator? If you want, Jared, you want to call on somebody? We got some hands over there.
Luke.
8/16. Okay. Now, looking at 8/16, I got to figure out my 16ths. Oh, goodness. Now, 8/16. I wonder how many spots that would take up. Does anybody know? How much would I use on my board? What would I make for 8/16? I have to come up with making 8/16 on my board. How big is that? Who has an idea? How big is a 16th? Do you have your little blue papers out? I lost my blue paper. Oh, how did I do that? Here it is. I can pull this paper out. One of these tells me what 16ths are. So 16ths are 1 square. How many squares do I have? So I have to do 1, 2, 3, 4, 5, 6, 7, 8. I have to make something this big. Jared, so you can do this on your own board. I'm going to have you go back to your seat. Thank you. So everybody do this. Do this on your board. Whoever's making the noise is going to stop. Okay, so I have this as my big area. This is 8 of these. Now, does anybody remember the name of this game? Okay, Reese is telling me what? Last equation wins. I have to make an equation. And you know what? If I'm going to be technical about this, Jared actually spun 8/16 that looks like this. If you would like to, you can do this. This is what he spun. And then you need to double check that you have your 8 of them. 1, 2, 3, 4, 5, 6, 7, 8. Okay, I have 8 of them. This is one of those things where we have to go slow with our game and explaining so you understand how to play it. For those of us in class, I actually made this into a workplace, so this will be one of the games you will play. Okay. So, how many of you think you want to help Jared come up with equations? Jared, you got some buddies behind you. Okay. I'm going to come up, well, Jared's, since Jared is, everybody says he's younger than me, so I guess I have to let him go first. Who can come up with an equation to equal 8/16?
Using just random numbers?
You have to use something that can work on here.
You could do
2/16 plus 6/16 equal, let's make certain. 1, 2, 3, 4, 5, 6. Okay, so here's 6/16 plus 2/16 equals 8/16. Okay, so now it's my turn. See, the youngest one gets to go first. Since you guys don't believe me that I'm 3. Yes, sir.
Tucker wants like.
Okay, Tucker, please stop. Okay, stop. Okay, it's already taken care of. Let's move on. I need to come up with my own fraction. And I'm thinking that I want to do something easy here. So I have 1, 2, 3, 4, 5, 6, 7, 8 of these. 8 times 1/16 equals 8/16. Okay, help Jared come up with another one. Because whenever you get stuck and you can't come up with any more, that's the person who won the round. Okay, so did you guys got something for Jared to say again? I can't hear ya.
16 plus 0, 16.
How many, what?
Is that 8/16 plus 0, 16?
That does work, but let's not go there with the 0/16 at the moment. Okay, so they said 1/16 plus 7/16 equal 8/16. Are you writing this down in your books? I didn't tell you to. I would like you to. Please turn to page 98 and make certain you're writing this down in your book so you have a reference on how to play. What do you think?
The one that she said.
Okay, so since we are playing a Bridges game, it would be in our Bridges workbook, page 98. So I need to come up with one. Let's see. I think that I am going to do 4/16 times 2.
Miss Radis, in my number corner book,
No, in the Bridges book.
In the Bridges book.
Yeah.
Okay. Okay, boys and girls, are you plotting? You coming up with an idea that Jared can do? Ooh. Oh, that you're not going to tell me. Okay, you got an idea of something that Jared can do again. Jared, call on somebody who has an idea. It doesn't have to be the boys near you. Okay. Okay, so they're doing it this way. 1, 2, 3/16 plus 1, 2, 3, 4, 5/16. 3/16 plus 5/16 equals 8/16. Well, I'm going to do 4/16 plus 4/16 equals 8/16. Remember I said 4/16 times 2, in other words, 1, 2, 3, 4, times another 1, 2, 3, 4. Okay, so I have mine done. So now it's Jared's turn again. I'll give you a moment. You can copy that down. Got to come up with the new one. Hey, Jared, call on somebody.
Does it have to be with the 16th on the bottom? Yes.
Well, let's read the directions and see. These are the directions. It says players take turns. Okay, the youngest goes first. Each player spins part of the fraction, and you create a fraction smaller than 1. Okay, and then the first player records a fraction below on the geoboard for round 1, and you draw we could draw the fractions if we want to. We should really do this. This would make life so much easier. Because this is that's the fraction we have. So if you didn't draw this in, do that. Each equation must show the fraction as either a sum of the other fractions with the same denominator, or the product of a whole number and a fraction with the same denominator. Equations with the same numbers but in a different order are considered the same because of the commutative property of multiplication and addition. So the last person who is able to write a unique equation wins. Okay. How many of you are realizing that we have a lot of combinations we could possibly do yet?
We didn't even do a division.
Okay. So, yes, sir. Oh, Jared, you got to call on him. He's got an idea.
4 times 2/16.
Okay, so we have 4 times 2/16. 4 times 2/16. 4 groups of 2/16. Here's a group. There's a group. There's a group. There's a group. It works. 4 times 2/16 equals 8/16. So now it's my turn. How about one group of 8/16? Okay. Okay, time to come up with another one. Oh, Carter's here to offer moral support. We're tied yet with one line to go. Are you guys able to figure out another one? Everybody's thinking. Ooh, do you understand how that works? So you said 16/16 divided by what? Okay, now are you sure that works? Do you know how to demonstrate that it works?
No.
Okay, so yes, sir. Do you know how to do that? Okay. The problem I'm getting into is some of you do not understand how this works and how to actually draw it. Yes, sir.
Well, it's basically just 16 divided by 2 because you do the denominator.
Okay. I'm going to ask you not to do division yet. This is not something we're going to go to in 4th grade. I don't want you to develop some bad habits. It'll be too hard to unlearn. So we're not going to go there. So this game is about building this. There are more combinations. Nope, it's about building it. Anybody kind of got an idea? There's some more. Are we done?
No.
Let's see. There's a few more that you could do yet.
How much? Like 10?
Do I give them a hint, Saphira?
Yes, yes,
No.
yes.
Just copy some off here.
How about that one?
You didn't tell us we could use. You didn't.
But you use 2/16 plus 6/16 up here.
I just add like 17 more. Oh.
So, yeah, that's what I mean. This game's going to end up in a draw.
How do you ever and
Some of the games, what if you spin 2/8? How many ways can you make 2/8? Think about that. Okay, so as you can see, there's many different ways. We could go 2/16 plus 3/16 plus 3/16 equals 8/16. Now, they pointed out that we could keep going on and on and on with this. So this game is a draw. So we figured out how to play one round. This is not an easy game to learn, but once you've learned it, it's actually a lot of fun because it really becomes a cutthroat competition. You try really, really hard to beat each other. Tomorrow, we're going to spend some more. Tomorrow, we're going to the school forest if it's not too snowy. Monday, we're going to practice this game again. So we're going to have to do a review, and we're going to practice this game again. The whole idea is understanding how to decompose this group of 8/16 into different equations. Okay, so we have to pack things up, so we're packing up a little bit sooner than we normally would. You guys enjoy the snowy weather. We're enjoying sunshine. It's going to be a beautiful recess. Okay, everybody say bye.
Bye. Bye.